So now we know how to create a basic for loop. Let's see how we can clean it up a little bit, make it a little bit easier to work with. I did say that these are used constantly inside your programs. So because they're used so much, programmers typically want to take as many shortcuts as they possibly can to make sure the process is easy. So what I'm going to show you is a few of the basic shortcuts we deal with. First and foremost is the counter variable name. Count is fine. In fact, you can use any variable name you want that's applicable to what you're doing at the time. You may be looking at all the elements of a row or something like that, so you might call your counter variable row. Or you might be looking at different index values of an array, so you might call your counter variable index. But commonly, the name of the counter variable is irrelevant. It's just helping us count through a certain number of iterations. So basically, programmers have shortened this down to simplify the process. So instead of using a variable name like count, they'll actually use a variable name like I or j. So we're just going to use I. We're going to just modify all this code here. So you can see that our code is already quite a bit smaller. It's still easy to read. We understand that I represents the iteration number that we're currently on, whether that's 400 and 512, whatever it is. And we can see in here that we're actually using that counter variable within the code. We don't have to, but in our cases it makes sense. So that's one step. The next step is how we modify or how we change the counter variable. Now this is a very common way, but we've seen other ways to do short versions of this. So we know that let's just create a dummy variable right here. Let's say int num. And let's say I give that a value of, I don't know, 5. Doesn't really make a difference. And I can now take steps and I can modify this stuff. So I can say num is equal to num plus 1. We're used to this. But we can also do something like this, num plus plus, which is the same thing. But maybe we don't want to add by 1. Maybe we want to add by a different number. We could say num plus equals, let's say 3, or 1 if we wanted to. But these are just different shortcuts that we can use in the place of this longer change statement. And commonly what you'll see is something more along the lines of this, I++. You can see that the signature line of the for statement is very lean now. There's no wasted space or code or anything like that, but it's still clear. It's very understandable. Loop from I is equal to 400 such that I is less than 600 and increase by 1 each time. Very simple. So that's our two shortcuts. The next thing we have to realize is that loops don't always have to count up. They can count down as well. So let's say instead of going from 400 to 600, I want to go from 600 to 400. So all I'd have to do is start my value at 600, and I want to keep looping not as long as I'm less than 400, but I want to keep looping as long as I am greater than or equal to 400. And I'm not increasing anymore. Now I'm decreasing. So it's still a loop. It's still going to go over the exact same number of iterations in this case, but it is going down instead of up. Another interesting thing that we can do is we don't have to count by ones. We could do anything we want. So for example, I might say minus equals 5. I can decrease by 5 each step. So I'm just going 600, 595, 590, and so on and so forth till I get down to 400. Now, let's say I was counting by, I don't know, 7s, for example. And I'm pretty sure that 7 is not an evenly divisible number by 200. So 600 to 400, it's not going to get up to exactly 400. It's going to pass that. It's going to go to like 390 something. But it doesn't matter because our test condition is saying keep looping as long as it's greater than or equal to. It's not going to stop at exactly 400. If it passes 400, that means it's still going to stop because it's no longer satisfying this test condition. So in the next video module, what we're going to do is we're going to show how to work with arrays. We're going to bring back to that first example from the very first video that we did on loops, and show how we can use this in a really effective way.